Hi, we're from Thermodynamics projects from Group 11. My name is Imthiaz bin Azlan. I'm from Negeri Sembilan. My ambition is to be an engineer and my hobby is playing games and badminton.
So hi, my name is Amir Akmal from Ipoh Perak. So my ambition is to become a good engineer which helps the community, and my hobby is to sleep.
Assalamualaikum. My name is Iman bin Ahmad Salodi Al-Tani. I live in Shah Alam, Selangor. And my ambition is to be a beneficial engineer. And my hobby is to play volleyball and video games. Moving on to our project, the question number 3 for A1. Since it's a compressor, the design will be like this. The inlet nozzle will be larger than the outlet nozzle. And for the data, P1 is 101 kilopascal, P1 is 70 degrees Celsius, P2 is 1000 kilopascal, T2 is unknown, and the Win is 522 kilowatt. Moving on to the next question, A2. So we're going to use the equation PV equal to MRT, and arranging the equation you get M equal to PV equal RT. And as stated, that is the digits for all the variables. And as we calculate, we will get 172.32 kilogram per minute. And multiplying with 1/60, you get 2.872 kilogram per second.
Alright, for the question 3A3, evaluate the temperature at the compressor exit, which is T2. We have in the question we have T1, that is 70 degrees Celsius, which converted to Kelvin is 290 Kelvin, and the enthalpy value which we get from the table is 290.16 kJ per kg. We can use this formula, and we have already calculated the mass flow rate from the question before this, 2.872 kilogram per second. We plug in all the values and we get the enthalpy value for state 2, which is 446.91 kJ per kg. And this value is in between 441.61 and 451.80. So we have to do interpolation, and we will get the temperature, which is 445.2 Kelvin.
So for question 3b, the question stated that it is an adiabatic turbine. So the first question asks us to find the power output. So this information, which is the inlet pressure, temperature, velocity and elevation for the inlet and outlet, is given in the question. So to find the power, first we have to find the enthalpy. So at pressure P equals to 2 megapascal, based from the table, it is superheated. So we refer the superheated table and we get the H value as 3248.4 kilojoule per kg. But when the pressure is 10 kilopascal, it is in the saturated region. So to find the enthalpy, we have to use the formula H equals to HF plus X HFG. So once you substitute each value, we will get the enthalpy as 2345.4 kilojoule per kg. So in order to get the power output, we will be using the energy balance equation, which is W dot equals to M dot times H1 minus H2 plus V1 square minus V2 square over 2 plus GZ1 minus Z2. So once you substitute each values, we will get the power output, which is 8.88 megawatt. But do bear in mind that for this equation, the velocity and the elevation must be divided by 1000 to change the unit into kilometer. So for the last question, which is to find the inlet area, we have to use the equation M dot equals to AV over specific volume. So once we substitute the value M dot, the volume and the specific volume, we will get the area, which is equivalent to 0.03024 meter cube.
Alright, for the closing, what we have benefited from this project, we have distributed the questions evenly throughout 3 of the members. And then we have discussed all the questions, so we can know which one we are wrong, which one we are correct, so we can correct each other.
Yes, and besides that, this project also helps us to boost our confidence in answering the questions, thus making us to be more prepared for our final exam. So with that, we hope that this project can help us to get good marks for our thermodynamics subject this semester. So that's all from us. Thank you.